Bruh, bruh, bruh.
If you wanna like
Do
your
what?
videos on.
Oh, sure.
Are you muted?
No, am I muted?
I feel like I'm
Okay, I'll just move it.
Yeah, talk somewhere not here.
Hi, everyone. Thank you for coming to our, presentation on intro to TensorFlow. So we're gonna go ahead and go through the basics of TensorFlow, basics of neural network, how it works, and then we're gonna do a little implementation of it. And where you guys will actually be able to code a little TensorFlow model. So yeah, my name's Alka. I'm Gayatri.
My name's Sai.
Yeah, we're part of the UD Google Development. So as a little introduction, what is machine learning? So machine learning is actually teaching a computer to learn and adapt to a specific problem and to provide solutions without explicit instruction. That's one of the things that is super interesting. When you're writing a program or a code, you have to write everything out, but machine learning does it automatically. And it ranges from learning how to identify space, or photo filters, or text generation, like ChatGPT, to the translator that you play on your phone. So these are different types of artificial intelligence and machine learning. So how do machine learning models work? So most models use something called a neural network to learn from provided data and then train themselves to recognize patterns and recreate those patterns with less data. So we're gonna go ahead and look into how a neural network works. So this is just a basic example of a neural network. As you can see, there's constant inputs, weighted sum and out. So I'm gonna go ahead and explain to you what they mean. So the inputs is here, they're also known as perceptrons. They identify features of a certain image. So let's say we have an image and we want to see, is this a dog or is it a cat? So the inputs would be like, does it have whiskers? Are the ears pointed? Things like that. And the weights would be how much this matters. So let's say one of the inputs is like, is it brown, right? So that input probably won't matter as much, because like both cats and dogs come in like different colors, and brown would be something that's shared in between. So we essentially take the inputs, which is a binary, 1 or 0. So like, does it have a tail or does it have whiskers, would be 1 or 0, and then multiply it with the weight, and then add them all together to a weighted sum, where we produce an output, which is either 1 or 0. And then as we get into more complex data types, we have a lot more inputs, and sometimes just deciphering does it have whiskers, does it not, is a little bit more complicated, because obviously with the machine learning model, the human eye can tell if they have this. Sorry, with the machine. Go ahead.
I didn't touch anything.
Okay, with the machine learning, with your eyes, you can determine if something has whiskers. But a machine learning model has multiple ways of doing that needs to use multiple inputs. So it'll look at the pixels, it'll look at the lines to determine this. So instead of just having one list of weighted sums and one output, there's multiple. And so these are called the hidden layers, and these are the.
I have to share my screen. Sorry.
And these are the layers that really make a neural network work. And then obviously there's the output layer, which gives you a binary output, 1 and 0. So what is TensorFlow? So that's a package that we're going to be using today and introducing to you guys today. So it's a free open source Python package.
Yo.
Sorry, technical issues.
Is it stop sharing again?
Yeah,
Bruh.
sorry about that. I hope you guys.
No, I was like,
Okay, get something with this.
Sorry about that. This is like very finicky, so just try. I'm sorry. I
Yeah,
have
you- Oh, shit.
okay.
Next one.
Okay, yeah, it's an open source package used for machine learning. It allows for rapid development using complex models and makes it simple and easier to implement machine learning models. And it has cross-platform different hardware capabilities. So TensorFlow really makes it easy for you to implement machine learning models because the previous slide I explained a neural network and before you would have to code that individually. TensorFlow just does it for you. Go ahead and next slide. Okay, so this is our example model. So what we are trying to do in our workshop right now is we're going to train our model to read handwritten numbers from images, and we're using a big data set called MNIC, which basically has a bunch of labeled images, a bunch of handwritten numbers, and then the label. So that would be a 7, and then obviously you can see the examples. TensorFlow uses the photos, they convert it to grayscale, so they convert every single image, and they have all the pixels, and the pixels range from 0 to 255, which is. It's happening because of the screen share.
Oh, wait. Here?
Sorry, okay, so, yeah, so it converts it to grayscale, and then eventually it looks through the pixels and identifies certain features of the pixels. So those are features would be, is it a line, is it straight, is it diagonal, do they have circles, and that's through the neural network or machine learning model. So that's a little bit of, the background that I explained earlier. And TensorFlow works with text data because it has a pre-trained model, so it makes it really easy to look through these data points because it's already trained. And they're then fed normally through the neural nets. So we're gonna go ahead and actually make you guys implement the model. So we can continue going along the code here and go ahead and type in that website to and it's gonna open a Google Collaborate notebook. You go ahead and copy that notebook.
Yeah.
And save it to your drive. If you are having any issues, feel free to let us know.
So if you just take a photo of it as well, because we want to go to the next slide and get the collab started, and we do have technical difficulties. Sorry, because we're sharing our screen. We're broadcasting this online as well. I'm just gonna have
Wait,
issue right now.
can you find it?
That we lose connection to the slide, but if you're not, we will also be sharing the slides and the collab, so don't worry too much about that. So we're just gonna reconnect and disconnect so far, but let's see, can we get the.
I think I
collab back
lost
up?
it.
Sorry about that. Sorry, we got technical Wi-Fi right now. There's a lot of people on it. We're trying to get that out. We just say, you guys can take your phone out and take a photo of this if you haven't already. You mind going back? One second.
The link is
Yeah.
just GDSC-TF.
Yeah.
The link is just GDSC/TF.
GSC-TF is a tiny URL.com. And I'm gonna pass it over to Sai and Gayatri, who will be walking through us this collab for today.
Yeah, you can go back.
Okay. Okay, thank you.
Yeah, just because that's my whole screen anyways.
Yeah, just share this and then run back to schedule. Yeah, could we put the tiny URL?
Look at it, you start talking to me.
All right, this is the code, so. Can we get bigger bit?
first things first, we need TensorFlow, because we're working with TensorFlow. So we import TensorFlow, and along with that, we also do data set, TensorFlow data set. This will be useful later on when we start parsing our data. And the final import that we have here is matplotlib. For those of you unfamiliar, matplotlib allows you to see data in the form of graphs. So you can actually see what you're looking at in a more organized way. So run that first. Like the little run phrases.
Bear with us with technical Wi-Fi. Code Lab is going to be running very, very slow.
Yeah. Okay, it's run. So we have those libraries imported. Now we can start using them. Scroll down. Our second piece of code. This is where we're trying to split our data. Now, if you take a look, we have two sort of input variables we're getting out of this. The data set train, data set test, and data set info. Data set info doesn't really help us later, it just shows us what information is here. The important thing is here is the data set train and data set test. Now, we have to separate this so that the model doesn't get fixated on the test on the data and just memorizes what the answers are. Yeah. Really. Is anyone else having issues with the import? Right. So, with the way that this is set up, we want to separate some of the data so that the model actually learns something and doesn't just memorize and give the answers. It's kind of like it's kind of like teaching, where we actually want the people to learn and not just memorize answers. So we separate it. The training data set is usually 80% of the data, and the testing data set is usually 20% of the given data. Okay, run that and just make sure it looks good. Okay, now that we parse that, this is the data set underscore info. This is what it looks like. So if you take a look here, the two things to look at specifically are the dictionary and how it's set up. So you have an image and a label. The image is what it is. Like, is it a handwritten 7, handwritten 6, handwritten 1? The label is the number itself. And what's it called? Each sort of data point has both of these values to allow the model to learn on what looks like a 7 and what looks like a 4, and so forth. And then here, the test data set. The test and in the splits, the test and the train. So the test takes up 10,000 of the data points, and the train takes up 60,000. This is usual behavior because we want them to train more, and we want the testing data sets to be separate so that it actually learns from the information that is given. And then there's some citation stuff, decently important. This is where it gets interesting. This is the first look at some of the values here. Now we're going through the data set training version, and we're showing the first actual value, TLC. That's where matplotlib comes into play. And can any of you tell me what this number is? You shot it. Perfect. It's a 4. Now we want the model to be able to do that too. And that's why we're trying to train it and see, this looks like a 4. This doesn't look like a 4, and so on and so forth. Okay, now this is where you guys will have to do a little bit of coding yourselves. Now, normalizing an image. What happens is we want to make sure all the images we give to our model is the same size. If we give one that's 20 by 20 and the model is, if it trains on all 20 by 20s and it's given like a 50 by 50, the model will probably be wrong because it doesn't know what's happening. So normalizing first, it makes sure that all of them are the correct size. Now, what's it called? What are some of the things that you believe we should add here? Now, we say that if we have an image. And we need to rescale the image between 0 to 1 by dividing it by 255. What do you think the code will look like? Any guesses? There are no wrong answers.
Isn't it simply just replace the HTML? Just in process so it doesn't like glitch out or anything like that. We're gonna.
Probably something like a 4 pixel image, pixel by equal. Sorry, next to.
So that's exactly right, but instead of doing 4 pixels on image, you don't
You
need
lose
to do
everything?
that, you just do divided by 255, and then we'll just do it in general for every single one. So that's.
I think all the tabs closed.
Simpler.
This is why all machine learning people use Python and not any other language. Python does a lot of work for you.
It's out.
Okay, well, yeah. So we're gonna do exactly what you said, we're gonna do image is equal
Yes.
to.
Are you able to do, like, what, the,
So the thing with convoluted neural networks is we use saying like, you know, what's a line or what's a diagonal or what's a circle, so we have a conceptual understanding of it. Realistically, when a neural network is doing it, they won't have these barriers. They'll probably use some sort of like granulated pixel image or mask that won't make sense to us. And so that's the beauty of the hidden layer. We don't see what's going on. So we're essentially putting on data and training, giving it different inputs so that it trains it correctly based on those inputs and then gives us some sort of an image. But what we can assume is that it does, and if you want, there are some layers where you can actually hardcore feature detection, which we're not doing right now. But yeah, in general, it would be way too much of a hassle to go ahead and try to look at those hidden layers, and it wouldn't make too much sense.
So we're setting the point a little bit even shorter. We can put like the success rate after each iteration and see how well it's doing. But we really don't have any idea how like an AI model is actually learning. That's the whole black box theory. We don't know what's going on. We just know it's working, it's not. Like we don't know exactly what's going on. So that's a big thing, but obviously we can see if it's improving or not.
As people who are really passionate about the field of machine learning, do you think that it's important to try to like